going to review exponent properties with you today. So I'm going to start with just the basic definition of an exponent when the base is b, and it could be any number except 0 or 1, and it's usually a positive number, anything except 0 or 1. And n, the exponent for now, we're going to think of it as a natural number, a counting number. So b to the n really just means to repeatedly multiply together the base, whatever it is. So it means b times b times b times b, n factors of b. Okay, so we'll try some exponent problems where there's a little pattern happening here, right? I'm keeping the base the same, it's always 2. I'm going to start with 2 to the third power. So that means 2 times 2 times 2. And so 2 times 2 times 2 is 8. Okay, 2 squared, or 2 to the second power, just means 2 times 2, and so that's 4. And 2 to the first power just means have one factor of 2, so it's just plain old 2. Okay, now if we look at the pattern here in our answers, notice that to go from 8 to 4, you're really dividing by 2. And to go from 4 to 2, you're dividing by 2 because you have one less factor of 2. And so math, we always like everything to be a pattern. It always has to, all the rules have to always work. And so if we're going to divide by 2, divide by 2, divide by 2 to get our next answer, that must mean that since 2 divided by 2 is 1, that must mean that 2 to the 0 power would have to equal 1. And that's exactly what it is. And so continuing on in that manner, thinking about this pattern of dividing by 2 and writing it in fraction form, if I take 1 and divide it by 2, that will give me 1/2. And if I take 1/2 and divide it by 2, which is the same as multiplying it by 1/2 again, I would get 1/4. And finally, if I divide by 2 again, my answer, my previous answer, to get this final one, I would get 1/8. And so notice that the positive exponents, 2 to the third, and the negative exponents, 2 to the negative 3, the answers are what we call reciprocals. So a negative exponent always means a reciprocal. It's not a negative number, a negative exponent is a reciprocal. So kind of from looking at that pattern and thinking about the ideas there, and the fact that there's a pattern involved, we can say that we've come to a few conclusions. Anything, doesn't have to be 2, right? Any base to the first power is just itself. So b to the first power is just b. But any base to the 0 power is going to equal 1. Okay, and that's kind of a place where there's common mistakes sometimes. So try and remember, think about why that's true. But any base to the 0 power will equal 1. Okay, and then finally, a negative exponent, if n again is a natural number, a positive counting number, then b to a negative power is a reciprocal. So it means 1 over b to the positive exponent, or it could mean the reciprocal of the base itself, 1 over b to the power. Notice that these two are equivalent algebraically. Okay, there are 5 basic exponent rules, so I'm going to review those very quickly. The first one could be called the product rule because it's how do you multiply exponential expressions with the same base. So if we have b to the m power times b to the n power, it's equal to that same base to the m plus n power. So you end up adding the exponents. And to see why that's true, if you take some really small, easy numbers to work with, for example, if we did b squared, b to the second, times b to the third, and just use our definition from before, b squared means b times b. b to the third power means b times b times b, right? So count them up. How many factors of b are there? 1, 2, 3, 4, 5. So that's b to the 5th. So you can see that, oh, we really needed to add the exponents there. Okay, the second rule is the quotient rule. And so if you have the same base, b to the m power, and you're dividing by b to the n power, in this case you keep that base and you subtract the exponents. And so again, taking easy numbers to kind of see why that works. If I took, for example, b to the 5th power, and I wanted to divide by b to the 3rd power, then I would have b to the 5th is b times b times b times b times b, just using the definition, 5 factors of b. And I'm dividing this time by b to the 3rd power. And so that's b times b times b. And so you can fraction where you're reducing or you're dividing common factors from both numerator and denominator. So if I reduce or divide by b and a second time and a third time, when I divide I get 1 left. And so I'm canceling out those common factors. I have left 2 factors of b in the numerator, and so that's b squared. So notice we just subtracted numerator exponent minus denominator exponent. The next rule is the power rule. So if I have an exponential expression raised to another power, you keep that main base and you multiply the exponents together. And so, again, trying to kind of see why that's true, why that works, take some easy numbers. So if I had, say, b squared to the third power, well, this exponent of 3, the base is b squared because of the parentheses. So that would really mean b squared times b squared times b squared again. But each b squared is b times b, so I've got b times b times another b times b times a third b times b. So again, count them up. 1, 2, 3, 4, 5, 6 factors of b. So that gives me b to the 6th altogether. And you can see then we really just had to multiply those exponents together. Okay, the next one is, what if your base is a product? So if you have parentheses and some multiplication in there raised to a power, the rule says that you apply the exponent to each factor in the base. So if we have ab in parentheses to the nth power, that's a to the nth times b to the nth. Okay, so for example, keeping it small numbers again, let's say I had something like ab to the third. Okay? Well, ab is in parentheses, so that's the base. That whole thing is the base of the third power. So that means ab times ab times ab. And then I can just use my commutative and associative properties, switch the order of the factors, and associate them together. And so by commuting and associating, I can collect up all my a's, right? So I have a times a, collect up all my b's, b times b times b. And so notice that's a to the third times b to the third. And so we had to apply that exponent of 3 to each factor of the base. Okay, the last one then is when your base is a quotient, when your base involves division. And so if your base has a fraction in it, like say a over b, and it's raised to the nth power, then the rule says that you apply the exponent to both numerator and denominator. And so again, if we just try a really easy small number for our exponent, let's say we have a over b just squared. Okay? Well, that whole thing is your base. So a over b is being squared, it's being multiplied with itself. Okay, but how do you multiply fractions? Well, you multiply the numerators and multiply the denominators. So as I multiply across my numerator, I have a times a. And as I multiply across in my denominators, I have b times b. And so a times a, that's a squared. B times b, that's b squared. So notice I had to apply the exponent to both the numerator and denominator.